Welcome back to the sleepy Geographer Tales, a quiet corner of the world that is anything but quiet, a place where the planet's deepest restlessness finds its voice. Tonight, we begin a story not of a single mountain or a lone earthquake, a place of fire and force that cradles the greatest ocean on Earth. Before we begin, I wonder, where are you listening from? Perhaps you're on the stable, ancient heart of a continent, far from any trembling ground. Or maybe you're on the coast, tonight listening to the Pacific herself sighing against the shore. If you find a sense of wonder in these hidden rhythms of our world, I would be so grateful if you gently tap the like button and subscribe. To those of you already here, thank you. You are the calm harbor from which we set sail on these journeys, and a small reassurance. I hope this tale of planetary unrest doesn't keep you awake. But if it does, may you drift into dreams with visions of deep Earth and fiery horizons. So, what is this realm? Imagine, if you will, a necklace of fire, a vast, unbroken seam of light and energy stretching nearly 40,000 kilometers around the Pacific. This is the Ring of Fire. It is not a single place, but a story written in the language of tectonic plates, whispered by volcanoes and shouted by earthquakes. It is a borderland, a place where the ocean floor, old and dense, meets the continents and, finding no other path, does the only thing it can. It turns downward. It plunges back into the earth from whence it came. And in that great descent lies the source of all this drama. From a distance, these places can seem the picture of serenity. Snow-capped peaks command awe. Hot springs offer comfort. The landscapes they create are among the most beautiful on our planet. But this beauty is a mask, a peaceful face on a restless heart. For this ring is a work in progress, a project of creation and destruction that has been underway for hundreds of millions of years and shows no sign of stopping. Let's take a brief journey around this ring. We begin in the south, where the Andes rise like a spine along the edge of a continent, their rocks folded and tortured by the immense pressure of the plates below. Travel north to the Cascades of the Pacific Northwest, where sleeping giants like Rainier and Hood stand silent guard over fertile valleys. Curve with me now across the northern Pacific, along the Aleutian chain, a string of volcanic islands where the Earth's fury meets the ocean's chill. Down through the intricate archipelago of Japan, a nation built upon the very meeting point of plates, where the Earth trembles as a daily reminder of its power. Further south, through the Philippines, a land of countless volcanoes and deep trenches. Through Indonesia, the very heart of the ring, where more volcanoes simmer than in any other nation on Earth. And finally, to New Zealand, a place where the Pacific Plate doesn't just dive, but grinds horizontally, shearing the land into breathtaking alpine landscapes. This is our stage, this rim of the Pacific. Here, the Earth never truly sleeps. It shifts, it simmers, it groans. It is a living, breathing system. And for the millions of people who call this ring home, this is not a geological abstraction. It is the ground beneath their feet. It is the source of both immense fertility and profound peril. In this series, we will trace the story of the Ring of Fire. We will dive to the deepest trenches where the plates begin their final descent. We will climb to the rims of craters to feel the heat and smell the sulfur of the Earth's interior. We will understand the science of the quake and the tsunami. We will listen to the myths born from the fear and awe of these powerful places. And we will meet the people who live with this reality, whose cultures are shaped by the constant presence of the planet's pulse. This is a journey, both outward and inward, into the science of subduction and magma, but also into the human spirit. that endures, adapts, and respects these incredible forces. So, let us begin this journey around the Pacific's restless rim. Let us explore the place where the Earth is at its most alive, its most creative, and its most destructive. Let us discover the Ring of Fire, a place where the planet reminds us, in no uncertain terms, that its story is still being written. Before we go further, I'd love to know where you've settled in to listen tonight. Perhaps you're in a room where the ground feels utterly solid, unquestionably permanent beneath you. That is a comfort I hope you keep. But what if I told you that the ground you trust is, in fact, adrift? If that thought sends a quiet shiver of wonder through you, I'd be so grateful if you gently tap the like button. It helps these quiet journeys find their way to others. And to those already here, thank you for returning. Your curiosity is the compass for this exploration. So, let us talk about this seemingly solid Earth we call home. Imagine, if you will, a simple egg. Its shell appears whole, a single, unbroken vessel, but tap it gently, and you'll find it is not a single, solid piece. It is a mosaic of tiny fragments, all held together in a delicate, fragile balance. Now imagine that egg scaled up to the size of our planet. The shell, this thin, brittle skin of rock we call the crust, is all we ever see, all we ever walk upon. But it is not one continuous sphere. It is shattered, cracked into a jigsaw puzzle of enormous fragments. These are the tectonic plates. And they do not sit still upon the molten rock below. They drift. They float on a layer of the Earth's mantle that is so hot it behaves like a slow, thick fluid over immense spans of time. This is the fundamental truth of our world. We live on the backs of these drifting giants. Their movement is unimaginably slow, measured in mere centimeters per year, the pace at which your fingernails grow. In a human lifetime, this motion is imperceptible. But grant them millions of years, and this slow-motion ballet becomes the most powerful force in shaping our planet. Oceans wider than any today have opened and closed. Continents have collided, merged and ripped apart again. Mountain ranges have been thrust skyward only to be worn down to their roots. All of it is the work of these plates, these fragments of a cracking eggshell forever in motion. And in the theatre of the Pacific, one plate plays the lead role in this drama, the Pacific Plate. It is the largest tectonic plate on Earth, a colossal slab of oceanic crust that covers most of the floor of the Pacific Ocean. It is the stage upon which the Ring of Fire is built. But a star is nothing without its supporting cast, and the Pacific Plate is surrounded by formidable neighbors. To the east, it meets the North American Plate and the smaller Juan de Fuca Plate. This is where the western edge of the United States and Canada is built. To the southeast, it interacts with the Cocos and Nazca Plates, which are themselves diving beneath the vast continent of South America. To the west, it converges with the Okhotsk Plate and the Philippine Sea Plate, a complex zone of interaction that shapes the islands of Japan and the Philippines. And in the south, it grinds against the Indo-Australian Plate. This immense, slow-motion collision of giants is the source of everything we associate with the Ring of Fire. Where these plates meet, the world is never at peace. Their boundaries are the seams of our planet, and it is along these seams that the Earth reveals its restless energy. But how? What happens when these immense, drifting slabs of rock meet? They can do one of three things. They can pull apart from one another, creating gaps where new crust is born. They can slide past one another, grinding horizontally in a friction that builds up and is released in violent jerks. Or, and this is the most crucial for our story, one plate can dive beneath the other. This process, the grand geological act of one plate descending below another, is the very heart of the Ring of Fire. It is the engine of its volcanoes, the source of its deepest earthquakes, and the architect of its tallest mountains. It is called subduction. And it is the reason. The Pacific Rim is a place where the Earth never sleeps, but that is a story for our next conversation. For now, I will leave you with this thought. The solid ground is an illusion of our brief lives. We are all, every one of us, passengers on these great drifting plates, moving through a silence so deep we cannot feel the motion. The ring of fire is simply where that motion becomes visible, where the immense, slow power of our planet cracks through the surface and reminds us of the magnificent forces that are always, quietly, at work. So, let us picture the meeting of two plates. On one side, the oceanic plate. It is made of basalt, a rock that is dense and heavy. It is also old, and over millions of years, it has become cold and weary from its journey away from the mid-ocean ridge where it was born. On the other side, a continental plate. It is made of granite, a rock that is lighter, more buoyant. It is like a cork floating on water. It will not sink. When these two meet, the dense, heavy oceanic plate does not have the strength to push the buoyant continent aside. There is only one path left for it. It must yield, it must bend, and it must descend. It begins to dive at an angle back into the hot, viscous mantle from which it originally came. This is subduction, the grand geological act of one plate, diving beneath another. Think of it as a lead blanket being slowly fed back into a furnace. But this is no simple process. The descent is not smooth. It is a violent, grinding, catastrophic collapse. The plates do not slide past each other willingly. They stick. They lock together along this colossal, downward curving fault line. Immense stress builds up as the relentless motion of the plates continues, trying to push the descending slab deeper. For decades, even centuries, nothing seems to happen. The strain builds in silence. Then, without warning, the locked zone can hold no more. It ruptures. The overriding plate, which had been forced downward and compressed for centuries, suddenly springs back upward. The energy released is unimaginable. It is the energy of 100,000 nuclear weapons detonating at once. It is a mega-thrust earthquake. The entire planet vibrates with the shock. This is the first, most violent product of subduction, but the drama does not end there. For as the oceanic plate descends, it journeys into hellish conditions. It is subjected to immense heat and pressure. It also carries with it the baggage of its oceanic life, vast quantities of waterlogged minerals and seafloor sediments. This water is not simply boiled away. It is driven out of the rock and into the hot mantle above the subducting slab. And here lies the true magic, the alchemy of subduction. This released water does something extraordinary. It drastically lowers the melting point of the hot mantle, rock above it. Think of salt scattered on an icy road. It lowers the freezing point of water and makes it melt. This water performs the same trick with rock. It causes solid mantle to begin melting, forming vast chambers of magma. This new magma is less dense than the surrounding rock. It is hot, mobile, and buoyant. It begins a relentless upward journey. It squirms and forces its way through cracks and weaknesses in the overlying continental crust, pooling in vast subterranean chambers. Some of it cools slowly underground to form great granite plutons, but much of it continues its ascent, eventually reaching the surface in a spectacular, fiery rebirth. This magma is the source of the volcanoes that define the Ring of Fire. Every majestic, cone-shaped stratovolcano, from Mount Fuji to Mount Rainier, is a direct product of this process. They are not random features. They stand in long, graceful arcs like a string of pearls, tracing the line where the oceanic plate is descending hundreds of kilometers below. They are the direct, visible proof of the slab's descent, the final exhalation of a plate that dove to its destruction. So, subduction is a cycle. It is the great recycler of the Earth's crust. It is where old, cold, dense ocean floor is destroyed, only to be reincarnated as new, fiery magma that builds continents and fuels volcanoes. It is a process of incredible violence that also gives life, creating the fertile soils that feed nations. It is the relentless engine that drives the Ring of Fire, a process where giants collide and from their collision, the world is remade. Imagine a map not drawn in ink but in fire, a cartography of force where the borders are not lines of politics but lines of immense geological tension. This is the true map of the Ring of Fire. To understand it, we must move beyond the simple outline and meet the individual characters in this drama, the great tectonic plates whose interactions write this story of flame and tremor. We have already met the protagonist, the Pacific Plate. It is the largest of them all, a vast expanse of oceanic crust that forms a foundational slab beneath almost the entire Pacific Ocean. It is the engine of the entire system, moving northwestward at a pace that, while slow, carries unimaginable momentum. But a protagonist is nothing without its supporting cast, and the Pacific Plate is surrounded by a formidable ensemble. To its east, along the coasts of North and South America, the Pacific Plate meets its continental neighbors, but the interaction is not uniform. In the Pacific Northwest of America, it doesn't meet the North American Plate directly. Instead, a much smaller plate, the Juan de Fuca Plate, is caught between these two giants. Think of it as a last crumbling fragment of a much larger ancient plate. The Juan de Fuca Plate is being relentlessly squeezed, subducting beneath the North American Plate. This is the source of the sleeping volcanic giants of the Cascades, Mount Rainier, Mount St. Helens, Mount Hood, and the silent building strain of the Cascadia subduction zone, a fault line with the potential for a catastrophic megathrust earthquake. Further south, along the coast of California, the dynamic shifts dramatically. Here, the Pacific Plate and the North American Plate refuse to subduct. Instead, they grind past one another horizontally along the infamous San Andreas Fault. This is a transform boundary, where the plates slide, storing and releasing energy. In a series of notorious earthquakes, this is a different kind of fire, a friction of side-to-side motion rather than the consuming fire of subduction. The story changes again as we look to the southeast. Here, the Pacific Plate interacts with two other oceanic plates, the Cocos Plate and the Nazca Plate. These plates, like the Juan de Fuca, are being subducted. The Cocos Plate dives beneath Central America, fueling the volcanic chains of Guatemala, El Salvador, and Costa Rica. The Nazca Plate, larger and faster, plunges at a steep angle beneath the western edge of South America. This is one of the most dramatic subduction zones on Earth. The force of this collision is so immense that it has crumpled the entire leading edge of the South American Plate, thrusting it skyward to create the majestic Andes, the longest continental mountain range in the world. The volcanoes that crown these peaks from Chile to Peru are the direct vent holes for the melting Nazca slab deep below. Now let us cross the Pacific. To the west, the Pacific Plate converges with a complex web of plates that form the intricate geography of Asia and the Western Pacific. It pushes against the Okhotsk Plate, on which northern Japan sits, and the Philippine Sea Plate, a small but incredibly active microplate. The interactions here are not always a clean subduction. In some places, the Pacific Plate subducts beneath these smaller plates. In others, like around Taiwan and the Philippines, the Philippine Sea Plate itself is subducting in a chaotic, clashing mess of geologic forces. This complexity is why this region is a spectacular fireworks display of volcanism and some of the most frequent and powerful earthquakes on the planet. Finally, in the south, the Pacific Plate meets the massive Indo-Australian Plate. The boundary here is a mix of transform faults and subduction zones. The Indo-Australian Plate is pushing northward, and in places like New Zealand, it is not subducting cleanly beneath the Pacific Plate, but rather colliding and grinding against it with tremendous force, shearing the land and building the dramatic Southern Alps along the Alpine Fault. This, then, is the true map. It is not a simple, single line. It is an intricate network of boundaries, each with its own personality and its own way of releasing the immense energy of plate motion. It is a map of consumption where oceanic plates dive to their destruction. It is a map of collision where continents are crumpled into mountain ranges. It is a map of friction where plates grind past one another. Every volcano, from the perfect cone of Fuji to the simmering calderas of Indonesia, is a precise dot on this map, marking a point where a plate is descending into the mantle. Every earthquake's epicenter is a stitch in this fiery seam. Together they trace the outline of the Pacific, not with ink, but with the relentless living energy of our planet, a constant reminder that the ground beneath our feet is part of a map that is still being drawn. Of all the mountains on Earth, none capture the imagination quite like the perfect cone-shaped volcano. Fuji in Japan, Mayon in the Philippines, Rainier in North America, these are the iconic sentinels of the Ring of Fire. They are not mere hills. They are impossibly steep, symmetrical, and often crowned with a wisp of steam, a silent promise of the power within. They are known as stratovolcanoes, and their birth is a direct and magnificent consequence of the subduction process. They are forged in the deepest earth, their very essence distilled from the descent of a tectonic plate. The journey to create a stratovolcano begins not with fire, but with water. As the oceanic plate bends and plunges into the mantle, it does not go alone. It carries with it a fortune in seawater, locked within the minerals of the basalt and trapped in the sediments that carpet the ocean floor. This water is the key ingredient, the catalyst for all that follows. As the slab descends into the increasing heat and pressure of the mantle, this water is literally cooked out of the rock. This released water then percolates upward into the hot, solid mantle rock that lies above the subducting slab. Here, it performs a kind of geological alchemy. Solid mantle rock, though incredibly hot, remains solid because of the immense pressure and its high melting point. But the introduction of water dramatically lowers that melting point. It acts as a flux, weakening the chemical bonds in the mantle rock. Suddenly pockets of it begin to melt. This is the genesis of the magma. It is not a simple melting of the subducting plate itself, but the melting of the overlying mantle triggered by the plate's watery gift. This new magma is fundamentally different from the basalt that erupts at mid-ocean ridges. It is infused with water and carbon dioxide, gases that were once part of the ocean floor. It is also enriched with silica, a compound that makes the magma thicker and more viscous, like peanut butter compared to the runny maple syrup of basaltic magma. This sticky, gas-charged brew is less dense than the surrounding solid rock. Buoyant and restless, it begins a slow, relentless ascent. It squeezes and forces its way upward through cracks and weaknesses in the overlying crust, a journey that can take thousands of years. It often pools in a massive subterranean chamber, a cauldron of incandescent liquid rock several kilometers beneath the surface. Here, it cools slightly and its chemistry evolves further. Minerals begin to crystallize out, making the remaining magma even more silica-rich and viscous. The pressure in this chamber builds as more magma feeds in from below and as the trapped gases struggle to expand. This sets the stage for the unique character of a stratovolcano, its explosive violence. The high silica content makes the magma too thick to allow gases to escape easily. Instead of bubbling out gently, the gases remain dissolved under tremendous pressure, like the CO2 in a shaken bottle of soda. The lid of rock containing the magma chamber is immense, but eventually the pressure from within becomes too great. The roof fractures, and the result is not a flow, but a detonation. The pent-up gases expand catastrophically, shattering the magma into countless fragments of ash and pumice and blasting them into the sky in a colossal plume. This is the eruption that makes headlines. But a stratovolcano is not built by explosion alone. In its quieter moments, thicker, pasty lava may ooze from the vent, cooling quickly into a rugged cap. This alternating pattern is the source of its name, strato for layers. A stratovolcano is a layer cake of its own history. One layer is ash from a violent explosive eruption. The next is a lava flow from a gentler event, then more ash, then more lava. Over hundreds of thousands of years, this cycle of destructive explosion and constructive flow builds the iconic, steep-sided, symmetrical cone. This is the forge. The subducting plate is the raw material, providing the water and the triggering mechanism. The mantle is the furnace where the heat is generated. The magma chamber is the anvil, where the brew is mixed and pressurized. And the final product, rising majestically and dangerously against the sky, is the stratovolcano. It is a monument to the cycle of destruction and creation, a peak born from the death of a plate, standing as a testament to the patient, fiery power that shapes our world. Not all mountains of fire are born from collision. Not all wear the classic steep-sided cone that defines the violent edges of the ring of fire. There is another kind of volcano, one that speaks not in explosive shouts, but in a low, steady whisper that builds empires of rock. These are the shield volcanoes, the quiet giants. And while the ring is defined by subduction, it also contains profound exceptions that prove the rule, places where fire rises not from the death of a plate, but from a mysterious plume deep within the earth itself. The story of a shield volcano begins not at the edge of a plate, but in the deep, silent mantle, far from the tectonic drama at the surface. Here, a phenomenon known as a hotspot is at work. Imagine a solitary candle burning steadily beneath the crust. This is a mantle plume, a column of superheated rock, rising slowly and relentlessly from the very edge of the Earth's core. It is a fixed point of intense heat in the moving frame of the tectonic world. As the rigid lithospheric plate above, it drifts steadily along. This stationary plume begins to burn a hole through it. This is the origin of the Hawaiian Islands. The Pacific Plate, the largest on Earth, has been moving northwestward for millions of years. Beneath it, a fixed hotspot has been pouring out magma. As the plate moved, the hotspot burned through it first to form the Kauai, then Oahu, then Maui, and now the big island of Hawaii itself. The islands are a chronological chain, a tape recording of the Pacific Plate's movement, with the oldest, most eroded islands in the northwest, and the youngest, most active volcano, Kilauea, directly over the plume today. The magma that rises from these hotspots is fundamentally different from the sticky, gas-charged brew of subduction zones. It is basaltic magma. It is hotter, thinner, and far less viscous. It is poor in silica and the volatile gases that fuel catastrophic explosions. Think of it not as thick, gaseous soda, but as dark, runny honey. When this magma finds a pathway to the surface, it does not explode. It effuses, it pours out. The eruptions of a shield volcano are therefore not events of terrifying violence, but often breathtakingly beautiful displays of fluid power. Fountains of incandescent lava may dance hundreds of feet into the air, but more often the lava simply wells forth from fissures and vents, flowing away in long, red-hot rivers. These rivers of molten rock can travel for dozens of miles, swallowing everything in their path with a quiet, unstoppable inevitability. They are not destroying the landscape so much as they are creating it, layer by painstaking layer. This style of eruption gives the shield volcano its name and its distinctive form. Because the lava is so fluid, it does not pile up into a steep cone. Instead, it spreads out into a broad, wide, gently sloping mound, resembling a warrior's shield lying flat on the ground. The sheer volume of rock produced is staggering. While a stratovolcano like Fuji is a majestic pinnacle, a shield volcano like Mauna Loa is a behemoth of mass. From its base on the seafloor to its summit, Mauna Loa is the tallest mountain on Earth, dwarfing Everest by over a mile. But its slopes are so gentle that to stand upon them is to barely perceive you are climbing a volcano at all. This is the power of the quiet giant. It is a power of accumulation, of patience. It is the geological tortoise to the stratovolcano's hair. Its eruptions can last for years, even decades, a constant, steady outpouring that slowly builds a new piece of the world. The entire island chain of Hawaii is a testament to this process. Every square inch of that paradise was built from countless such flows, each one adding a thin new layer to the land. Yet to call them quiet is not to say they are without risk. A river of lava is no less destructive for being slow-moving. It will consume forests, towns, and highways with a serene, apathetic certainty. And even these placid giants can have moments of dramatic transformation. The summit caldera of Kilauea can collapse in breathtaking fashion, and the flank of a shield volcano can suffer catastrophic landslides that send entire sections of the island sliding into the sea, potentially triggering devastating tsunamis. The existence of these hotspots within the Ring of Fire is a crucial reminder. The ring is not a single, simple process. It is a symphony of geological forces. The dominant melody is the crashing cymbal of subduction, creating the violent, explosive stratovolcanoes that form the ring's outline. But beneath that there is a steady, deep bass note, the hotspots. They represent a deeper, more primordial connection to the Earth's interior, a heat that rises independently of the surface dance of the plates. They are the quiet giants, building their broad, peaceful empires in the very heart of the restless Pacific, proving that true power does not always need to shout. The most familiar sound of the Ring of Fire is the explosive roar of a volcano. But there is another, more profound and terrifying voice that the Earth uses. It is not a sound of fire, but of breaking stone. It is a deep, subterranean roar that begins as a shudder, builds into a violent convulsion, and can end in a silence more dreadful than the noise itself. This is the earthquake, and the most powerful of them all, the megathrust earthquake, is born directly from the immense, grinding collision of tectonic plates. We have spoken of subduction, of one plate diving beneath another. But this process is not smooth. It is not a gentle slide. The boundary between the two plates is a vast, complex landscape of rock, millions of years of accumulated seafloor sediments, and immense irregularities. As the subducting plate tries to drag itself downward, it becomes locked against the overriding plate. The motion does not stop. The plates continue to drift, their immense momentum unchecked. But the friction along this locked zone is too great to allow any sliding. It is a titanic stalemate. Imagine trying to push a colossal, immensely heavy wardrobe across a rough, concrete floor. You lean into it, straining with all your might, but it does not budge. The energy of your effort is not gone, it is being stored. It is transferred into the bending of the wood, the compression of the casters, the building strain in your own muscles. This is what happens to the Earth's crust. For decades, or even centuries, the plates remain locked. The overriding plate is forced to compress and bulge upward, storing elastic energy like a spring being compressed. The strain builds in utter silence, a pressure cooker tightening with each passing year. Then in an instant, the friction fails. The lock breaks. The stored energy is released catastrophically. The section of the overriding plate that had been dragged downward and compressed for centuries suddenly springs back upward in a colossal, violent rebound. This is the moment of the megathrust earthquake. The rupture can propagate along the fault line for hundreds of kilometers, and the slip, the distance the plates suddenly move, can be tens of meters. The energy released is beyond human comprehension, equivalent to tens of thousands of nuclear weapons detonating at once. This energy radiates out from the rupture point in the form of seismic waves. The first to arrive are the P waves, or primary waves. These are compressional waves, much like sound waves, that push and pull the rock in the direction they are traveling. They are fast, but often feel like a sudden, sharp jolt. Shortly after come the S waves, or secondary waves. These are shear waves that move the ground up and down and side to side. They are slower but far more destructive, shaking the very foundations of the world. Finally, come the surface waves, which roll across the ground like waves on the ocean, causing the earth to undulate and heave, responsible for the most widespread damage to buildings and infrastructure. The location of this rupture deep beneath the ocean floor triggers the earthquake's most devastating side effect. The sudden upward thrust of the seafloor displaces an enormous volume of water, pushing it upward into a mound that then collapses under gravity. This sets in motion a series of waves that race across the ocean at the speed of a jet airliner, a tsunami. Out in the deep ocean, these waves are barely noticeable, but as they approach the shallow coastline, they slow down and pile up into walls of water that can devastate entire regions. The aftermath of such an event is a world altered. The land itself may be permanently uplifted or dropped down by several meters. Coastlines are redrawn. The rupture has released centuries of built-up strain, but it has also transferred that strain to adjacent, still locked sections of the fault, often bringing them closer to their own breaking point. The Earth's roar is not a singular event, but a conversation along the fault line. This is the science of the quake. It is the physics of friction and stored elastic energy on a planetary scale. It is a process where the slow, patient, invisible strain of centuries is released in minutes of unparalleled violence. The megathrust earthquake is the ultimate expression of the subduction zone's power, a stark reminder that the ground beneath our feet is not a passive platform, but an active participant in the dynamic and often unforgiving system of our planet. It is the sound of the Ring of Fire's most fundamental process, the sound of the Earth itself roaring in protest as its plates grind inexorably forward. The earthquake's roar is terrifying, but it is not always the end of the story. For those living on the shores of the Ring of Fire, the most profound danger often arrives not from the ground below, but from the ocean beyond. It comes not as a shudder, but as a wall of water. It is the tsunami, a word that carries a specific and dreadful weight, far beyond the misnomer tidal wave. Its genesis is not in the pull of the moon, but in the violent dislocation of the Earth itself, most often by the very megathrust earthquakes we have just described. The process begins once again at the subduction zone. During a megathrust event, a vast section of the seafloor, hundreds of kilometers long, suddenly lurches upward by several meters. This is not a subtle movement. It is the instantaneous, catastrophic thrust of a portion of the planet's crust. Imagine lifting a colossal paddle from the bottom of the ocean and shoving it upward with unimaginable force. In that single moment, an enormous volume of water is displaced. You cannot push such a quantity of water aside. You can only lift it. This uplift creates a mound of water on the surface of the ocean, directly above the ruptured fault. It is a hill of ocean, perhaps only a meter high, but stretching the entire length of the rupture. But the stability of the ocean has been profoundly violated. Gravity immediately acts, pulling this mound back down and trying to restore the ocean's flat equilibrium. But the energy of the displacement is too great. Instead of settling calmly, it radiates outward in all directions, generating a series of waves, a tsunami wave train. Out in the deep, open ocean, these waves are deceptively gentle. They can travel at speeds exceeding 800 kilometers per hour, the velocity of a jet airliner, with wavelengths, the distance from one wave crest to the next, stretching 100 kilometers or more. Because of this immense length, the wave height in deep water might be only a meter. A ship on the open sea would likely not even notice it passing underneath. It would experience a slow, gentle rise lasting several minutes, followed by an equally slow and gentle fall. The power is there, but it is hidden in the wave's length and speed, not its height. The transformation begins as this wave train approaches the shallow water of a coastline. The leading edge of the wave begins to drag on the sloping seafloor. This friction slows the wave down dramatically, but the water behind it is still moving at immense speed. This compression forces the water upward. The wave's energy, once spread over a vast depth, is now concentrated into a much smaller column of water. The wavelength shortens drastically and the wave height grows precipitously. What was a barely perceptible swell in the deep ocean becomes a towering, steep-fronted wall of water. It is this final, brutal transformation at the shoreline that unleashes the tsunami's devastating power. It does not arrive as a classic, curling breaker. It arrives as a fast-rising, violent surge, a rapidly incoming tide that does not stop. It is a torrent of water filled with debris, shattered buildings, cars, trees, that acts less like a wave and more like a horrifically powerful, dense slurry, scouring the land clean of everything in its path. The force of the water is immense, capable of crushing concrete and bending steel. And often it is not a single wave, but a series, with the second or third wave sometimes being the largest and most destructive. While megathrust earthquakes are the most common cause of ocean-wide tsunamis, they are not the only one within the Ring of Fire. The same volcanic forces that build islands can also tear them down in a way that unleashes the ocean's wrath. On the flanks of many volcanic islands, both above and below the waterline, lie enormous deposits of unstable rock and sediment. These can be triggered to collapse by a volcanic eruption or a large earthquake. When a large section of an island, say the size of a small mountain, shears off and plunges into the ocean, it acts like a gigantic plunger. It displaces a colossal volume of water instantaneously, generating a tsunami with terrifying local ferocity. These volcanic landslide tsunamis can be particularly devastating for nearby coastlines, as the wave can arrive within minutes, offering little to no warning. The same geologic violence that builds the beautiful islands of the Ring of Fire also contains the seeds for their destruction. This, then, is the ocean's wrath. It is not a separate phenomenon, but a direct and deadly extension of the earthquake and the volcanic eruption. It is a reminder that the domains of earth, water, and fire are not separate. A convulsion in one can unleash a nightmare in another. The tsunami is the ocean's answer to the earth's roar, a silent, racing, deep ocean messenger that delivers the full, horrifying force of a tectonic collision directly to the shore. It is the Ring of Fire demonstrating that its power is not confined to the land, but can command the very sea. We have spoken of volcanoes that build mountains and earthquakes that shake the ground, but there is another kind of power within the Ring of Fire, one so vast and slow-moving that it defies the very image of a mountain. This is the hidden fury of the supervolcano. It does not rise in a perfect cone. It instead broods in a colossal depression, its power concealed beneath a tranquil landscape of hot springs and geysers. These are not makers of mountains, but potential unmakers of worlds, and they represent the most catastrophic force the Ring of Fire can muster. Forget the familiar shape of Fuji or Rainier. A supervolcano begins with a magma chamber of an entirely different order of magnitude. While a typical stratovolcano is fed by a chamber perhaps a few dozen kilometers across, a supervolcano's source is a vast, seething reservoir of molten rock hundreds of kilometers wide, sitting much closer to the surface. This is not a mere pocket of magma, it is a continent-scale blister of liquid rock. For hundreds of thousands of years, this chamber fills, fed by a relentless plume of heat from the mantle. The pressure inside builds to unimaginable levels, not over centuries, but over millennia. The crust above this immense reservoir begins to dome upward, not into a peak, but into a vast, gentle swell. The land rises sometimes so slowly that it is imperceptible to generation after generation of humans living upon it. This is the calm before the storm. The surface above may give hints of the inferno below, geysers like Old Faithful in Yellowstone, roaring fumaroles and hot springs bubbling with chemical-rich water. These are not merely tourist attractions, they are the surface vents of a deep, planetary fever. The land is literally cooking from below. Then the roof can hold no more. The pressure from the buoyant magma and expanding gases becomes greater than the strength of the miles-thick rock lid containing it. The collapse is not an explosion upward, but an implosion downward. The entire center of the domed crust, and area the size of a large metropolis, catastrophically fractures and plunges into the magma chamber. This sudden collapse opens a vast pit, and only then does the eruption begin in earnest. It is the largest volcanic explosion possible on Earth. The eruption is not a single blast, but a catastrophic evacuation. The magma chamber empties itself. In a matter of days, the material erupted is not measured in lava flows, but in thousands of cubic kilometers of ash, pumice, and gas. The eruption column would blast through the stratosphere, injecting billions of tons of fine ash and sulfur, aerosols high into the atmosphere, circling the globe. The sky would darken for years. The finest ash would form a global haze, reflecting sunlight back into space and plunging the planet into a volcanic winter. Temperatures would drop dramatically, agriculture would fail worldwide, and ecosystems would collapse. This is not a local disaster. It is a planetary-scale event that could threaten the fabric of human civilization. Within the Ring of Fire, the most famous of these systems is the Yellowstone caldera in North America. Its last super eruption occurred over 600,000 years ago and left behind a caldera so large, 50 by 70 kilometers, that you can scarcely perceive its boundaries from the ground within it. The entire park is a testament to the restless energy below. But Yellowstone is not alone. In New Zealand, Lake Taupo fills the caldera of a supervolcano. Its most recent super eruption, the Oruanui eruption, about 26,500 years ago, was one of the most violent of the last 100 millennia. The lake itself is beautiful, serene, and surrounded by lush forests. It is a place of recreation and peace, belying its cataclysmic origin. The Maori have legends that speak of the event, a cultural memory of the sky turning black and the land being reshaped by fire. Today, Taupo is still active. It has had smaller eruptions in the centuries since humans arrived in New Zealand, a quiet reminder that the system is not extinct, only sleeping. This is the essence of the supervolcano threat, its sublime disguise. There is no looming peak to fear, only a peaceful landscape that hides a sleeping dragon. Their timelines are geological, operating on scales of hundreds of thousands of years, making the chance of an eruption in our lifetime vanishingly small Yet their very existence is a humbling reminder of the raw, planet-altering power that resides beneath the thin shell of the Earth's crust. They are the ultimate expression of the Ring of Fire's might, not as builders of iconic peaks, but as forces that can, when they finally stir from their long slumber, change the world itself. Japan is not merely a country with volcanoes, it is a nation built by them, defined by them, and forever living in their shadow and their grace. To travel through the Japanese archipelago is to journey across the back of a restless geological giant. Here, the abstract forces of the Ring of Fire are rendered intimate, personal, and deeply woven into the cultural soul. This is not a place where people merely endure the Earth's power. They have learned to respect it, venerate it, and find a profound beauty in its peril. The geology is breathtakingly complex. Japan is the product of a tectonic car crash, a convergence of no fewer than 4 major plates: the Pacific Plate subducting beneath the Okhotsk Plate in the north, the Philippine Sea Plate subducting beneath the Eurasian Plate in the south. This intricate dance of collision and subduction means the very ground is under constant, immense stress. It is squeezed, fractured, and compressed, giving Japan its rugged, mountainous interior and its precarious position along the Pacific Rim. This is why the Earth trembles here almost daily, a constant, low-level reminder of the forces below. It is also why the country is home to over 100 active volcanoes, a line of fiery peaks that form the iconic spine of the islands. From this volatility springs an unexpected blessing: onsen. The countless natural hot springs that dot the landscape are the gentle gift of the volcanic heart. The same subduction that fuels eruptions also heats water deep within the earth, which then rises to the surface, mineral-rich and steaming. For centuries, these geothermal baths have been centers of community healing and relaxation. To soak in an outdoor onsen surrounded by snow with the faint scent of sulfur in the air is to experience a direct and peaceful connection to the very forces that could, on another day, bring destruction. It is the volcano's warm embrace. This duality of danger and benefit is central to the Japanese relationship with the land. The volcanoes are not seen as mere threats, they are kami, sacred spirits. Mount Fuji is the most famous example, an active volcano that is also the nation's most potent symbol of beauty, endurance, and spiritual ascent. Pilgrims have climbed its slopes for centuries in a ritual of purification, but countless other mountains are also sacred. Shinto shrines, often painted a brilliant vermilion, stand at the bases of these peaks, gateways to the realm of the gods. The volcanoes are revered, prayed to, and appeased. This spiritual framework is a way of understanding and coping with a power that is ultimately beyond human control. This acceptance is matched by a culture of meticulous preparedness. Japan possesses the most advanced earthquake early warning system in the world. Seconds matter, and alerts buzz on millions of phones moments after a tremor is detected, giving people a precious instant to brace. Drills are a routine part of life from kindergarten onward. Buildings are engineered with sophisticated counterweights and flexible frames designed to sway with the shaking, not resist it. Tsunami evacuation routes are clearly marked along coastlines. This is a society that has institutionalized resilience, transforming anxiety into action through technology, education, and community protocol. The landscape itself tells the story of past fury. The caldera of Mount Aso in Kyushu is one of the largest in the world, a vast grassy plain encircled by cliffs, inside which new volcanic domes continue to smolder. The infamous Mount Unzen, whose pyroclastic flow killed journalists and volcanologists in 1991, stands as a somber monument to the cost of this beauty. The Great Kanto earthquake of 1923 and the Tohoku earthquake and tsunami of 2011 are not historical footnotes, They are scars on the national consciousness, events that shaped modern Japan and reinforce the understanding that the ground can betray in an instant. Yet life flourishes in the shadow of this threat. The volcanic soil is incredibly rich and fertile, supporting intensive agriculture. The mountains provide fresh water, forest resources, and define the breathtaking scenery that defines the Japanese aesthetic. The constant presence of impermanence, known as mono no aware, a gentle sadness for the transience of things, permeates art, literature, and philosophy. It is an awareness that beauty and catastrophe are intertwined, that life is precious, precisely because it is fragile. To live in Japan is to understand the Ring of Fire not as a distant concept, but as a daily reality. It is to feel a slight tremor, and after a pause to confirm it is minor, simply continue with your meal. It is to hike a beautiful forested trail and see vents steaming from the rocks. It is to honor a mountain as a god, while simultaneously monitoring its every gasp and rumble with a network of seismometers. It is a masterclass in coexistence, a demonstration that humanity can live with immense natural power, not through domination, but through respect, preparation, and a deep cultural acknowledgement that we are mere guests on a living, breathing, and ever-changing earth. The western edge of North America holds a secret. It is a landscape of profound beauty, of mist-shrouded forests, deep fjords, and snow-capped peaks that seem to embody permanent serenity. But this peace is an illusion. This region, from northern California to British Columbia, sits atop the Cascadia subduction zone, a sleeping giant whose occasional stirrings remind everyone that this is not a place of rest, but a place of immense gathering tension. This is the Pacific Northwest, where the geologic drama of the Ring of Fire is playing out in slow motion, building towards an inevitable, catastrophic release. The story begins, as always, with the collision of plates. Out in the Pacific, the small but dense Juan de Fuca plate is relentlessly driving eastward, sliding beneath the North American plate upon which the continent is built. But here, the process is not smooth. The plates are locked. They are stuck together along a fault line that runs for hundreds of miles offshore. The immense force of the moving plates continues to push, but the friction is too great to allow any sliding. The North American plate is being compressed, dragged down and bent like a giant spring being wound tighter and tighter. For over 300 years, this spring has been coiling. The strain has been building in utter silence. This is the silent threat of Cascadia. It is not a question of if this locked zone will fail, but when. When it finally ruptures, it will be a megathrust earthquake of staggering magnitude, likely between 8.7 and 9.2. The entire region will lurch westward by several meters. The shaking will last for 4 to 6 minutes, an eternity in seismic terms, and will devastate infrastructure from Seattle to Portland to Vancouver. But the initial quake is only the beginning. The sudden uplift of the seafloor will displace a colossal volume of water, generating a tsunami that will reach the coast in as little as 15 to 30 minutes. The waves will not be gentle. They will be a violent, debris-choked surge that will scrawl a new, horrifying coastline. The landscape itself is a monument to this ongoing collision. The Cascade Mountain Range, with its iconic cone-shaped volcanoes, is the direct volcanic expression of the subducting Juan de Fuca plate. As the plate descends, it releases water into the mantle, which melts the rock above, feeding the magma chambers that fuel these fiery peaks. They are known as the Cascade Volcanic Arc, a direct parallel to the volcanic arcs of Japan and the Andes. Among these sleeping giants, two stand as powerful symbols of the region's latent power. Mount St. Helens is the reminder of what these mountains can do. Its catastrophic 1980 eruption was a violent lateral blast that obliterated hundreds of square miles of forest, not a gentle effusion of lava. It was a terrifying demonstration that Cascade volcanoes can be explosively violent, and its now iconic cratered summit is a permanent scar, a lesson in the raw power of pent-up magmatic gases. Then there is Mount Rainier. If St. Helens is the lesson from the past, Rainier is the worry for the future. It is not merely a volcano, it is a massive, unstable edifice of rock and ice. Its summit is crowned with more glacial ice than any other peak in the lower 48 states. The greatest threat from Rainier is not a traditional eruption, but a phenomenon known as a lahar. These are catastrophic volcanic mud flows triggered when an eruption, or even just a large earthquake, rapidly melts the glaciers, mixing water with loose rock and volcanic debris into a concrete-like slurry that can race down river valleys. At highway speeds, the valleys leading from Rainier are not empty. They are densely populated suburbs of Tacoma and Seattle. Ancient lahar deposits underlie these towns, a silent testament to past disasters. A major lahar today would be one of the most devastating geologic disasters in North American history, burying communities under meters of mud and debris in a matter of minutes. The peculiar challenge for the Pacific Northwest is its modernity. Unlike Japan, where centuries of seismic activity have forged a deep cultural memory of preparedness, the Cascadia subduction zone has been quiet during European settlement. The last megathrust event occurred in 1700, a fact confirmed by both indigenous oral histories and Japanese records of an orphan tsunami. This long silence has bred a dangerous complacency. Cities are built on liquefiable soil, schools and hospitals are not all retrofitted, and public awareness, while growing, still lags far behind the scale of the threat. This is the essence of the Pacific Northwest. It is a place of breathtaking beauty, but that beauty is the direct product of a terrifying geologic force. The lush forests, the fertile valleys, and the majestic skyline of the volcanoes all exist because of the subduction zone below. The giant is sleeping, but its sleep is fitful. It grumbles with small quakes and steams from volcanic peaks. The people who live here are learning to listen to its breathing, to prepare for the day when the 3-century silence finally and violently breaks. They live on the edge of a landscape that is still being born, waiting for the moment when the earth reminds them of its power. The Ring of Fire does not merely dot the edge of a continent. In South America, it is the edge of the continent. Here, the planetary process of subduction has not just built volcanoes, it has forged the longest continuous mountain chain on Earth, a colossal spine of rock that defines the very shape of a continent. This is the Andes, a 7,000-kilometer-long testament to the enduring, violent collision between the oceanic Nazca Plate and the continental South American Plate. It is a landscape of breathtaking scale, born from and continually shaped by the most powerful forces of the Ring of Fire. The story of the Andes is one of relentless compression. For over 200 million years, the Nazca Plate has been diving eastward beneath South America at one of the fastest subduction rates on the planet. But this is not a clean process. The leading edge of the South American Plate is too thick and buoyant to be easily pulled down. Instead, it is being crushed. Imagine a slow-motion car crash where one vehicle is forced underneath the other, and the second vehicle responds by crumpling upward, its hood buckling into a massive fold. This is the Andes. The entire western margin of the continent has been squeezed, folded, and thrust upward, layer by layer, over millions of years, creating a high, complex barrier between the Pacific Ocean and the continental interior. This ongoing collision manifests in two spectacular ways. The first is the sheer height and breadth of the mountain range itself. This is not a single, narrow ridge, but a series of parallel cordilleras, high plateaus, and deep valleys. The Altiplano, in Peru and Bolivia, is one of the highest plateaus on Earth outside of Tibet, a vast wind-swept plain sitting at over 3,700 meters elevation, nestled between even higher mountain peaks. This is the result of the crust being not only uplifted, but also thickened to almost double its normal depth under the immense horizontal pressure. The second manifestation is the volcanic arc that crowns the range. As the Nazca Plate plunges into the mantle, it releases its water, triggering the melting that feeds a line of volcanoes. These are not the solitary sentinels of the Cascades. They are often massive complexes built upon an already towering base. Volcán Ojos del Salado on the Chile-Argentina border is the tallest volcano on Earth, its summit reaching 6,193 meters. These peaks are young, restless, and part of one of the most volcanically active regions in the world. Their eruptions are typically explosive, laden with ash and pyroclastic flows, adding new layers of rock to the ever-growing mountains. Yet the building up is only half the story. The forces of erosion work tirelessly to tear it all down. The Andes are so high that they create their own climate, wringing moisture from the air and creating extreme contrasts. On the western slopes, the Atacama Desert, the driest place on Earth, exists in the rain shadow of the mountains, a barren landscape of stunning aridity. Meanwhile, on the eastern slopes, torrential rains feed the headwaters of the Amazon, carving deep, dramatic gorges through the freshly uplifted rock. The landscape is a constant battle between the titanic uplift from below and the relentless scouring by ice, wind, and water from above. For the people who live here, this geologic reality is the foundation of life. The Andes are not a barrier to be crossed. They are a home to be navigated. Ancient civilizations like the Inca mastered these vertical landscapes, building terraces into the steep slopes and cities at breathtaking altitudes. Today, millions live in high-altitude cities like La Paz and Quito, their cultures and physiologies adapted to the thin air. The minerals concentrated by volcanic activity have been both a bounty and a curse, fueling empires and conflicts. The fertile volcanic soils support agriculture on the mountainsides, while the glaciers clinging to the highest peaks provide a critical reservoir of fresh water for millions downstream. The constant threat of the Ring of Fire is also a part of life. Earthquakes here are frequent and often powerful, a result of the sticking and slipping of the subduction zone. The threat of volcanic eruption is ever present, but there is also a deep reverence for the mountains, or apus, as sacred spirits that provide protection and sustenance. This spiritual connection is a profound recognition of the power that shaped the world around them. The Andes, therefore, are more than a mountain range. They are the most dramatic and visible evidence of the Ring of Fire's power to build continents. They are a living, growing, eroding, and breathing entity. They remind us that subduction is not just a destructive force, it is the planet's primary mountain-building engine. To stand in the shadow of these peaks is to stand at the foot of a process that began deep beneath the ocean floor, a process that continues to push the skyward, slowly and inexorably reshaping the face of our world. On the southern edge of the Ring of Fire, the rules of engagement change. This is not a story of one plate diving meekly beneath another. Here, in the dramatic landscapes of New Zealand, two continental giants meet not in a collision of subduction, but in a grinding sideways struggle for dominance. This is a different kind of tectonic battle, one that has sheared an entire nation in two and created a landscape of breathtaking beauty and profound instability. This is the story of the Alpine Fault, a place where the Ring of Fire shows its teeth in a spectacularly different way. The protagonists in this drama are the Pacific Plate and the Indo-Australian Plate. For the most part, the Pacific Plate is the one subducting around the ring, but along the western coast of New Zealand's South Island it will not yield. Here, the Pacific Plate is carrying a continental fragment of its own, and it meets the Indo-Australian Plate head-on. Neither is oceanic and dense enough to easily subduct, neither is willing to back down. So instead of a dive, the meeting becomes a ruthless horizontal grind. The boundary between them is the Alpine Fault, one of the longest, straightest, and most significant geological faults on Earth. Imagine placing the palms of your hands together and pushing, but then slowly sliding, one hand forward and the other backward. This is the motion along the Alpine fault. The plates are sliding past each other, but with a crucial additional force. They are also pushing together. This combination of sideways motion and intense compression is what makes the fault so unique and so potent. It's a transform boundary with a massive component of uplift. The result is not a line of volcanoes, but a massive mountain range thrust skyward by pure tectonic force. This is the origin of the Southern Alps, or Katiritiri o Te Moana in Maori. This breathtaking range, with its jagged peaks and glaciers, is being forged directly by the sideways grind of the plates. As the two plates scrape past one another, the edge of the Indo-Australian plate is being rammed upward, crumpling the crust and pushing the mountains higher at a rate among the fastest in the world. Erosion from the prodigious rainfall on the western flank fights a constant battle, carving deep valleys and fjords, but the tectonic uplift is winning, creating a landscape of extreme relief and young, rugged rock. The motion along the fault is relentless. The plates are moving horizontally relative to each other at about 3 centimeters a year. They are also locked, just like a subduction zone. For decades, even centuries, the fault remains stuck, not moving at the surface. But the plates keep pushing, storing immense elastic energy in the rocks. The entire western side of the South Island is being bent, warped, and compressed, waiting for the inevitable release. When the Alpine fault finally ruptures, it will not be a traditional subduction earthquake. It will be a major strike-slip event, but one of incredible power due to the immense compression involved. Geological evidence from trenches dug across the fault tells a clear and sobering story. It ruptures in a full-length earthquake on average every 300 years. The last one was in 1717. The next is, in geological terms, due. When it goes, it will likely be a magnitude 8.0 plus earthquake. The sideways lurch will be sudden and violent, with the land west of the fault shifting northward by up to 8 meters in a matter of seconds. The shaking will be intense and prolonged, triggering massive landslides in the steep Southern Alps. For the people of New Zealand, the Alpine fault is a known and studied threat. There is no subduction zone tsunami to fear here, but the direct shaking and its secondary effects will be catastrophic. The fault is not hidden offshore. It is a visible scar on the landscape, running for hundreds of kilometers. This visibility has allowed scientists to study it in detail, and the populace, much like in Japan, has a strong culture of seismic awareness and preparedness, though the long gap since the last event presents a challenge of modern complacency. The Maori have long recognized the power of this place. Their traditions speak of the creation of the land by the god Raki, Sky Father, and Papatuanuku, Earth Mother, being forced apart by their children. The wrenching pain of this separation is echoed in the landscape itself. The mountains are not just scenery, they are ancestors and living entities. The fault is a source of both creation and destruction, a concept that aligns perfectly with the geological reality. The Alpine fault is the Ring of Fire's southern crown. It demonstrates that the Pacific Rim is not a monolith. Its violence is not expressed solely through volcanoes and diving plates. Here it is expressed through a monumental, horizontal shearing, a slow-motion tear that has built one of the world's most dramatic mountain ranges. It is a stark reminder that the Earth's crust can fracture and move in different ways, each with its own unique brand of power and peril. New Zealand is a nation born from this sideways struggle, a beautiful, precarious land forever being shaped by the immense grinding force of two continents that refuse to yield. If the Ring of Fire has a heart of pure chaotic energy, it beats in the archipelago of the Philippines. This is not a place of simple, single subduction. Here, the tectonic forces are a tangled, violent knot. The nation is not built upon the stable edge of a continent, but perched precariously on a complex system of microplates, caught in a relentless squeeze between titans. The result is a land of unparalleled seismic and volcanic intensity, where the Earth's unrest is a constant, shaping presence in the lives of its people. The Philippine Islands themselves are a geologic patchwork, a collection of volcanic arcs, fragments of oceanic crust, and folded sedimentary rocks all mashed together by millions of years of compression. The dominant force is the convergence of two major plates, the Eurasian plate to the west and the Philippine Sea Plate to the east. But between them, like a seed between two grinding stones, is the tiny Philippine Mobile Belt. This small, adaptable microplate is being twisted and deformed by the colossal forces acting upon it. The boundaries are not clean lines, but zones of intense, multifaceted violence. To the west, the oceanic portion of the Eurasian plate is subducting eastward beneath the Philippines, forming the Manila Trench and creating a chain of volcanoes on the western side of the islands, like Mount Pinatubo. To the east, the dense Philippine Sea Plate is subducting westward, plunging under the archipelago along the Philippine Trench, the second deepest trench on Earth. This eastern subduction fuels another, even more active line of volcanoes, including Mayon and Taal. This dual subduction is unique. The archipelago is being compressed from both sides, a geologic vice that explains the incredible frequency of earthquakes. The plates do not slide smoothly. They stick and lock, building strain that is released in powerful, often shallow quakes that can cause devastating damage directly under populated islands. The country shakes with thousands of tremors every year, a constant reminder of the fragile ground beneath. But it is the volcanoes that define the landscape and the imagination. The Philippines is home to over 20 active volcanoes, each with its own personality and peril. They are not solitary sentinels, but a crowded community of fiery peaks. Mayon Volcano in Luzon is renowned for its almost perfect symmetrical cone, a geometric beauty built by countless eruptions. Its very perfection is a testament to the consistent, predictable nature of its eruptions, a steady, terrifyingly graceful outpouring of lava and ash. Then there is Taal Volcano, a volcano within a lake within a volcano. Its caldera holds a lake, and on that lake is a small island which is the main volcanic vent. That vent itself holds a small crater lake. This nested, surreal geography is a picture of volcanic complexity. Taal is one of the world's most active and dangerous volcanoes, not because of its size, but because of its proximity to millions of people and its tendency for violent, steam-driven eruptions caused by the interaction of magma and the surrounding water. And of course, there is Pinatubo. Its cataclysmic 1991 eruption was a defining event of modern volcanology. A colossal explosion of ash and gas cooled the entire planet for years and reshaped the surrounding landscape, burying vast areas. In lahar flows, Pinatubo became a stark lesson in the global impact of a local eruption and the critical importance of monitoring and evacuation. Living in this environment has forged a culture of resilience and deep respect. The constant threat is met not with despair, but with a pragmatic and spiritual acceptance. Volcanoes are both feared and revered. They are killers that have buried towns, but also life-givers whose rich soils support lush agriculture and sustain communities. This duality is deeply ingrained. People farm on the fertile slopes of Mayon, even as they watch it steam. They live in the shadow of Taal, drawn by the bounty of the lake, even while knowing its history of violence. Preparedness is a part of life. The Philippine Institute of Volcanology and Seismology, 5 maintains a vigilant watch, its networks of sensors providing crucial early warnings. Drills are common in schools and communities. The sound of sirens is a known and heeded call to action. This is a society that has learned to listen to the Earth's rumblings and to move with its rhythms. The Philippines, therefore, is the ring of fire in its most concentrated and complex form. It is a place where the planet's dynamics are laid bare without the simplifying order of a single subduction zone. It is a vortex of colliding plates, rising magma, and shaking ground. To be in the Philippines is to understand that the Earth is not a solid, reliable platform, but a dynamic, living system. It is to live with a constant, low-grade hum of unrest, a beautiful, dangerous, and utterly captivating reality where the fiery heart of the planet feels closer to the surface than anywhere else on Earth. Stretching along the equator like a string of emerald and fire, Indonesia stands as the undisputed volcanic empire of the world. This vast archipelago of over 17,000 islands is the beating, fiery heart of the Ring of Fire, home to more active volcanoes than any other nation on Earth. It is a land where the planet's inner fire does not merely simmer beneath the surface. It constantly, visibly, and violently remakes the world. Here, the geological processes are not abstract concepts. They are the very authors of the landscape, the architects of culture, and agents of both creation and cataclysm on a scale almost beyond comprehension. The reason for this concentration of power is its position at a tectonic crossroads of breathtaking complexity. Indonesia is squeezed between the immense Eurasian plate to the north and the Indo-Australian plate to the south. The Indo-Australian plate is driving relentlessly northward, subducting beneath Sumatra, Java, and the lesser Sunda Islands at a steep angle. This creates a deep oceanic trench and a corresponding volcanic arc that forms the spine of these islands. But the story is even more intricate. To the east, the Pacific plate adds to the pressure, colliding and subducting in a chaotic zone that has forged the complex geography of Sulawesi and the Moluccas. This multi-plate collision creates an unparalleled density of subduction zones, each one feeding superheated magma into the crust below. The result is a nation built by volcanoes. The islands of Java, Bali, and Sumatra are essentially volcanic products, their fertile soils and dramatic skylines the direct result of millennia of eruptions. Every aspect of life is touched by this reality. The soil, enriched by volcanic ash, is incredibly fertile, supporting vast plantations of rice, tea, and coffee that terrace the slopes of the very mountains that could destroy them. Water heated by subterranean furnaces bubbles up in hot springs used for bathing and ritual purification. The volcanoes are not just landmarks, they are spiritual entities, revered as sacred homes of gods and ancestors. This deep cultural reverence is a form of wisdom, a way of living with a power that cannot be controlled, only respected. Yet this relationship is also etched with tragedy, for Indonesia's volcanic history is punctuated by eruptions of legendary, world-altering ferocity. Two events stand as stark reminders of the empire's destructive might. In 1815, Mount Tambora on the island of Sumbawa unleashed the largest volcanic eruption in recorded history. Its explosion was heard over 2,000 kilometers away. The eruption column shot ash and sulfur dioxide high into the stratosphere, encircling the globe. The following year, 1816, became known as the Year Without a Summer across Europe and North America. Global temperatures plummeted, crops failed, and famine spread, all because of an event on a remote Indonesian island. Tambora's eruption was a horrific demonstration of how a local geological event could trigger a global climatic catastrophe, a reminder that the threads of our world are intimately and delicately connected. Then, in 1883, Krakatoa, or more accurately, the volcano that occupied that space, vanished in a series of explosions so powerful they were heard across 10% of the Earth's surface. The final blast is considered the loudest sound in modern history. The eruption triggered tsunamis that killed tens of thousands of people along the coasts of Java and Sumatra, wiping out hundreds of villages. The ash turned the sky red around the world for months, inspiring artists and fueling apocalyptic fears. But from this utter destruction came new life. The child of Krakatoa, Anak Krakatau, has been growing steadily from the caldera since 1927, a powerful symbol of the planet's relentless drive to create, even from the ashes of its own destruction. Living in this empire requires a profound resilience. Monitoring agencies are constantly vigilant, tracking the rumblings of dozens of restless peaks simultaneously. Evacuations of hundreds of thousands of people are a periodic and necessary reality. The memory of more recent disasters like the sudden, lethal phreatic eruption of Mount Merapi in 2010 or the unexpected tsunami triggered by the flank collapse of Anak Krakatau in 2018 is fresh. The people understand that beauty and peril are two sides of the same coin. Indonesia, therefore, is more than just a country with many volcanoes. It is a living testament to the raw, creative, and destructive power that built the Ring of Fire. It is a place where the Earth's mantle feels disconcertingly close to the surface, where the air sometimes carries the scent of sulfur, and where the ground is both incredibly fertile and fundamentally unstable. It is a nation whose very existence is a dialogue with fire, a continuous lesson in the humility required to live on a planet that is very much alive and capable of rewriting its own surface in a single fiery breath. The name Pompeii echoes through history as the ultimate symbol of a civilization frozen in a single catastrophic moment by a volcano's wrath. But the Ring of Fire holds its own, equally profound time capsule, not in the shadow of Vesuvius, but nestled in the scenic Shimabara Peninsula of Japan. This is the story of Mount Unzen and the ancient city of Shimabara, a disaster that unfolded not in a single fiery cataclysm, but in a slow, terrifying, and ultimately deeply human tragedy that has earned it the somber title of the Pompeii of the East. For years the mountain had grumbled. Starting in 1791, Mount Unzen began a period of unrest, a prelude to the main act of devastation. Earthquakes became frequent visitors to the region, a constant, unsettling reminder of the power sleeping beneath the fertile fields and bustling streets of the city below. The eruptions began in February of 1792. They were not initially catastrophic, but rather a persistent, frightening series of lava flows and pyroclastic surges from the volcano's flanks. For months, the people of Shimabara lived under a pall of smoke and ash, their lives dictated by the mountain's mood. The disaster did not arrive as a rain of fire from the main summit. Instead, it was triggered by the very structure of the volcano being compromised. Scientists now believe the prolonged eruption destabilized the entire eastern flank of the mountain, a huge dome called Mayuyama. After over a year of rumbling and shaking, the Earth could hold no more. On May 21, 1792, the entire side of Mayuyama collapsed in one of the largest volcanic landslides in history. An estimated 0.34 cubic kilometers of rock, a mountain within a mountain, sheared off and hurtled downward at terrifying speed. But the horror was only beginning. The colossal landslide slammed into the Ariake Sea with the force of a planetary impact. The displacement of water was instantaneous and apocalyptic. It generated a massive tsunami, a wall of water that roared back towards the coast with unimaginable fury. The wave, estimated to have been over 50 feet high, smashed into the coastline of Shimabara and swept across the bay to devastate the opposite shore. It was this tsunami, not the eruption itself, that was the primary agent of destruction. Over 15,000 people were killed in minutes, making it Japan's deadliest volcanic disaster. Entire villages were simply erased, scoured from the earth by the wave, and here the story converges with Pompeii. The landslide debris and the subsequent tsunami inundation buried parts of the city of Shimabara under a thick layer of mud and rubble. Unlike the superheated pyroclastic flows of Vesuvius that carbonized organic matter, the mud and water from Onsen acted as a cooler, wetter preservative. It sealed away a snapshot of late Edo period Japan, protecting it from the ravages of time and later development. The archaeological significance of this burial is profound. Excavations have revealed the remains of samurai homes, merchant shops, and commoner dwellings, offering an incredibly detailed cross-section of a feudal Japanese city. The volcanic debris preserved not just the stone foundations of buildings, but the intricate layout of streets, drainage systems, and even personal artifacts. Items of wood, lacquerware, and textiles, organic materials that usually decay, were preserved in the anaerobic, waterlogged environment. This provides a uniquely complete picture of daily life, social structure, and material culture that is often missing from historical records. Perhaps the most poignant archaeological finds are the footprints. In the hardened mud, researchers have discovered the preserved footprints of people and animals fleeing the disaster. These are not just impressions. They are frozen moments of sheer panic, a direct and heartbreaking connection to the human experience of that terrible night. They tell a story of a frantic, desperate flight, a race against an invisible and unstoppable force. The legacy of Onsen is thus twofold. It is first a memorial to loss, a stark reminder that the greatest danger from a volcano is not always from the sky, but from the catastrophic collapse of its own unstable edifice. It forever changed the understanding of volcanic hazards in Japan, highlighting the secondary threat of landslides and tsunamis. Secondly, it is a scientific and historical gift. The buried city provides a window into a world that would have otherwise been lost, offering insights that written records alone could never provide. It stands as a powerful counterpart to Pompeii, demonstrating that volcanoes can preserve as well as destroy, and that even from the most profound tragedies, we can recover invaluable knowledge. Mount Onsen's story is not one of instant oblivion, but of a prolonged dread and a final devastating wave, a testament to the complex and often unexpected ways the Earth reminds us of its power. Of all the eruptions that have scarred the Earth, none in recorded history has so profoundly demonstrated the fragile interconnectedness of our world as the 1815 explosion of Mount Tambora on the island of Sumbawa, Indonesia. This was not a local disaster, it was a global event. It did not merely reshape a landscape, it altered the climate of the entire planet, leading to a year of such profound misery and strange weather that it would be etched into the memory of nations as the year without a summer, a period of famine, disease, and cultural shift born from a volcanic cataclysm. The event began, as these stories often do, with a series of rumblings. In April of 1815, Tambora, a massive stratovolcano, began to awaken. Its initial eruptions were heard hundreds of miles away, mistaken for the sound of distant cannon fire. But on the evening of April 10th, the mountain culminated its fury in a paroxysmal explosion that defies comprehension. It was the largest volcanic eruption in over 1,300 years. The top 4,000 feet of the mountain vanished in an instant, replaced by a colossal caldera 6 kilometers wide and over a kilometer deep. Pyroclastic flows raced down the slopes at hurricane speeds, obliterating the entire kingdom of Tambora and killing tens of thousands of people instantly. The sound of the blast was heard over 2,000 kilometers away, but the true reach of Tambora's power was not in its blast, but in what it injected into the stratosphere. The eruption lofted an estimated 150 cubic kilometers of ash and, more importantly, 60 million tons of sulfur dioxide gas high above the weather systems of the planet. This gas, mixed with water vapor, to form a vast, microscopic haze of sulfuric acid aerosols, a gleaming, sun-blocking shield that began to encircle the globe. This aerosol veil was a perfect mirror, reflecting a significant portion of the sun's incoming radiation back into space. The Earth's thermostat had been suddenly, violently turned down. By the summer of 1816, the effects of this global shroud became terrifyingly apparent. In the northern hemisphere, the seasons seemed to break. Frosts blackened crops in New England in June and July. Snow fell in Albany, New York in August. In Europe, the summer never arrived. Endless rains soaked the continent, rivers swelled into destructive floods, and crops rotted in the fields. The price of grain skyrocketed. Famine stalked the land from Ireland to Switzerland. Starving crowds rioted for bread in cities across France and Britain. In China, unseasonable cold killed rice crops, leading to devastating floods and famine. The climate system of the entire planet had been knocked profoundly out of balance by a single event on a remote Indonesian island. The human toll was staggering. Perhaps 200,000 people perished in Europe alone from starvation and the typhus and cholera epidemics that followed in the wake of famine. It was a slow-moving global catastrophe whose cause was a complete mystery to the people suffering through it. Many saw it as a biblical punishment or a sign of the end times. The scientific understanding of atmospheric circulation and volcanology was still in its infancy. They had no framework to connect their miserable cold summer to a volcano on the other side of the world. Yet from this period of darkness emerged unexpected sparks of creativity. The bizarre weather forced people indoors for much of the year. In a villa on Lake Geneva, a group of friends, trapped by the incessant rain, decided to have a contest to see who could write the most frightening story. From that contest, born from the gloomy atmosphere of that volcanic summer, Mary Shelley conceived her masterpiece, Frankenstein, a tale of creation and unintended consequences that eerily mirrored the natural world's rebellion. Lord Byron wrote his apocalyptic poem, Darkness, and his physician, John Polidori, created The Vampire, a forerunner of the vampire genre. The Year Without a Summer stands as a humbling lesson on a planetary scale. It was the first event to clearly show humanity that our climate is not a local phenomenon, but a single, interconnected system, vulnerable to being knocked askew by a single, powerful geological event. It demonstrated that the Ring of Fire's influence extends far beyond its fiery rim. Its eruptions can whisper into the jet stream, dictate the success of harvests on another continent, and shape the course of human history. Tambora did not just bury a kingdom. It cast a pall over the entire world, a stark reminder that we all live under the same fragile atmospheric dome, and that a cough from the earth in one corner of the globe can make the whole planet shiver. To live within the Ring of Fire is to understand a fundamental truth. The ground beneath your feet is not a passive stage, but an active participant in life. It is a relationship built not on domination, but on a hard-won resilience, a continuous adaptation to forces that cannot be controlled, only endured and respected. From the steep slopes of the Andes to the dense cities of Japan, the communities that call this volatile rim home have woven the constant threat of earthquake and eruption into the very fabric of their cultures, their architecture, and their spiritual lives. This is not a story of fear, but one of profound adaptation. The most visible sign of this resilience is written in stone, steel, and wood. It is the architecture of flexibility. In Chile, a country accustomed to some of the most powerful earthquakes on the planet, engineers have pioneered some of the world's most advanced seismic design. Skyscrapers in Santiago are not built to be rigid. They are designed to sway. They are equipped with massive pendulum dampers, huge counterweights suspended in the top floors that swing opposite to the building's movement, absorbing the energy of the shake. Other structures sit on immense rubber and lead base isolators. that effectively decouple the building from the trembling ground, allowing the earth to move while the structure floats almost undisturbed. This is not mere engineering. It is a philosophical acceptance of motion, an attempt to dance with the earthquake rather than resist it. In Japan, this principle extends downward to the very foundations of daily life, the iconic tokonoma alcove. In a traditional Japanese home used for displaying art, often has a lip on its edge to prevent precious objects from falling during a tremor. Modern furniture is secured to walls, and elaborate systems of nets are installed over shelving in stores. Building codes are among the strictest in the world, constantly updated with lessons from each new quake. The goal is not to prevent damage entirely, but to create a life-safe environment, a pragmatic focus on ensuring survival above all else. But resilience is more than a technical problem. It is a spiritual and communal one. Throughout the Andes, volcanoes are not seen as inanimate threats, but as living deities known as apus, powerful mountain spirits that command respect. Communities make offerings, pagos a la tierra, to these peaks, giving coca leaves, alcohol, or llama fetuses back to the earth to ensure balance and placate the mountain's temper. These rituals are not superstition. They are a cultural framework for understanding and coping with a power far greater than themselves. They are a way of maintaining a relationship, of showing gratitude for the fertile soil the volcanoes provide while respectfully asking for protection from their fury. In Japan, the Shinto religion imbues natural forces, or kami, with spirit. Mountains, forests, and particularly volcanoes are seen as sacred dwellings of these gods. This deep-seated reverence translates into a culture of preparedness that is both collective and instinctive. The annual September 1st Disaster Prevention Day is a national event, with millions of people participating in simultaneous drills. School children practice ducking under their desks instantly at the first alarm. Households maintain meticulously stocked emergency go bags with water, food, a radio, and a hard hat. This is a society that has institutionalized mindfulness about disaster, transforming anxiety into practiced, calm readiness. This communal aspect is perhaps the most critical element of resilience. In the wake of disaster, social bonds become the most vital infrastructure. In Chile and Japan, the immediate response to a major earthquake is not chaos, but the emergence of highly localized self-organizing communities. Neighborhood associations, long established for social purposes, instantly pivot to distribute aid, check on the elderly, and share information. This deep social capital, the knowledge of who lives on your street and a willingness to rely on one another, is a form of defense as crucial as any seawall or reinforced concrete. The adaptation is also etched into the landscape itself. In Indonesia, some villages located in the fertile but perilous shadow of volcanoes practice a rotational farming system, understanding that the land must be used and then left fallow, a tacit acknowledgement of the mountain's cycles. In the Philippines, the ancient Banawe rice terraces are not just an agricultural marvel. They are a feat of erosion control, a way of stabilizing steep, earthquake-prone slopes through intricate, community-maintained earthworks that have held for millennia. To live on the edge is to cultivate a different sense of time and permanence. It is to understand that buildings and even lives are transient, but that community and culture endure. It is to build with the expectation that the ground will eventually move, and to find grace and ritual in that uncertainty. The peoples of the Ring of Fire have not conquered the tectonic forces that surround them. Instead, they have learned the deepest form of respect, the respect that comes from listening to the earth's rumblings, from preparing for its temper, and from never, ever taking its stability for granted. Their resilience is a quiet, daily practice, an ongoing conversation with a restless planet. Long before the language of tectonic plates and subduction zones existed, The people of the Ring of Fire bore witness to its power. They felt the ground tremble and tear, saw the sky darken with ash, and watched mountains of fire bloom from the earth. Faced with such awesome, terrifying force, the human mind sought explanation and meaning. Science would come later. First came story. The violent phenomena of the ring were not random events. They were the actions of gods, the struggles of giants, and the consequences of cosmic battles. This rich tapestry of myth is the original geology, a profound attempt to explain the world through narrative. In the volcanic archipelago of Japan, the Earth's unrest is woven into the very foundation of the Shinto religion. The islands themselves were born from the divine union of Izanagi and Izanami, whose stirring of the ocean with a jeweled spear created the first land. Volcanoes are not mere mountains, they are sacred beings, the dwelling places of kami, or spirits. Mount Fuji is revered as the home of Konohana Sakuya, the goddess of the volcano and of life itself, whose beauty is as fleeting and brilliant as cherry blossoms, a metaphor for the sudden, beautiful, and destructive potential of an eruption. Earthquakes were explained by the giant catfish, Namazu, who lives buried in the mud beneath the earth. Normally, the god Kashima restrains Namazu with a mighty stone. But when Kashima's attention wavers, Namazu thrashes about, causing the ground to shake. These stories were not mere fantasy. They were a cosmological framework that made the unpredictable predictable. They gave a reason for the chaos and offered a way to interact with it through ritual, prayer, and respect. Across the Pacific, along the spine of the Andes, ancient peoples looked upon their volcanic peaks and saw not inanimate rock, but living conscious deities, the Apis. These powerful mountain spirits were the owners of the land, the source of water, and the arbiters of life and death. A rumbling volcano was not a geological process. It was an angry Apu expressing its displeasure. To placate them, the Inca performed elaborate capacocha ceremonies, making offerings of exquisite goods and sometimes human sacrifices, often children, on the summits of high peaks. The perfectly preserved ice maiden of Mount Ampeito is a haunting testament to this belief, a child offered to soothe the mountain's temper. The earth itself was Pachamama, the Earth Mother, a fertile but sometimes wrathful entity who had to be thanked and appeased with offerings for her bounty and her stability. An earthquake was her shudder of discontent. For the ancient Greeks, who lived on the far western edge of the ring's influence, volcanic activity was the work of the god's greatest craftsman. The forge of the god Hephaestus was said to lie beneath Mount Etna in Sicily. The rumblings of the mountain were the sound of his divine hammers striking the anvil, and the eruptions were the sparks and flames from his workshop. Earthquakes were the domain of Poseidon, the earth shaker. When angered, he would strike the ground with his trident, causing the land to split and the seas to roar. This attribution of power to a specific moody deity explained the suddenness and violence of seismic events. The ground didn't shake without reason, it shook because a god was furious. The Maori of New Zealand tell the story of Ruaumoko, the god of earthquakes and volcanoes. He is the youngest son of the Sky Father, Rangi, and the Earth Mother, Papatuanuku. When his parents were forced apart by their children to bring light to the world, Ruaumoko was still at his mother's breast. He was carried down into the earth, where he remains to this day. His stirrings and movements as he seeks warmth are the cause of earthquakes. The steam from geothermal vents is his breath, and volcanic eruptions are his fiery anger. He is also the god of the seasons, linking the fertility of the land with its violent underground energy. These myths from every corner of the Pacific share a common thread: personification. The unknown force is given a name, a face, and a personality. This transforms a random, terrifying, and meaningless event into a purposeful action. If the ground shakes because a god is angry, then there is a logic to it. More importantly, there is a recourse. One can pray, make offerings, build a shrine, or perform a ritual. Myth gave people agency in a world otherwise defined by helplessness in the face of nature's raw power. This ancient wisdom, born of observation and storytelling, often contained intuitive truths that prefigured scientific understanding. The Maori story of Ruaumoko dwelling within the earth intuitively grasped the concept of internal geothermal heat. The Japanese myth of the restrained catfish captured the essence of built-up seismic strain suddenly being released. Today we understand the mechanics of subduction and magma chambers. We have satellites and seismographs, but the myths remain. They are not outdated falsehoods, but the deep cultural bedrock upon which modern understanding is built. They represent a timeless human response to wonder and terror. They remind us that the Ring of Fire is not just a geological feature, it is a character in the human story, a shapeshifter who has been a god, a giant, a demon, and a creator, forever challenging us to find meaning in the chaos. We have spent our journey together exploring the raw power of the Ring of Fire, a power that for millennia was understood only through the language of myth and the stark evidence of catastrophe. The gods were restless, the giants were fighting, and humanity could only watch, pray, and endure. But the story of our relationship with this power is not static. We have not remained passive observers. In a profound shift, we have begun to learn the Earth's language. We have built a modern oracle, not of priests and prophecies, but of silicon, steel, and algorithms, all aimed at a single, impossible goal: predicting the unpredictable. This modern divination is not about claiming certainty. It is about listening for the whispers of the Earth, interpreting its subtle tremors and exhalations to gauge its mood. The work of volcanologists and seismologists is one of intense, patient observation, a constant vigil kept at the world's most dangerous thresholds. The tools of this vigil are diverse, each designed to measure a different symptom of the planet's restlessness. Let us consider the volcano first. Monitoring its pulse involves a suite of technologies. Seismometers are the stethoscopes. They are scattered around a volcano's flanks, listening for the constant, subtle music of the Earth. The character of this seismicity is the key. Harmonic tremor, a constant, low-frequency hum, can indicate magma moving through underground. Conduits. Swarms of tiny, shallow earthquakes, known as volcano-tectonic events, can signal the fracturing of rock as magma forces its way upward. But the oracle does not listen only, it also watches. Tiltmeters and GPS units measure the most infinitesimal deformation of the volcano's surface. As a magma chamber inflates beneath the ground, it causes the entire mountain to swell, much like a balloon stretching as it is filled. Detecting this bulging, sometimes a matter of millimeters, can provide crucial warning that pressure is building. Gas sensors sniff the air, measuring the composition and volume of gases like sulfur dioxide and carbon dioxide escaping from fumaroles. A sudden increase in gas output or a change in its chemistry can be a sign that fresh, gas-rich magma is approaching the surface. From the sky, satellites equipped with radar, INSAR map ground deformation across vast areas with incredible precision, revealing the invisible inflation and deflation of entire volcanic regions. They can even detect the heat anomalies of new lava domes. This constant flow of data is streamed to monitoring stations where it is woven together to create an evolving picture of the volcano's state. The forecast is not a specific day and hour, but a rising probability, an escalating alert level that tells authorities when to warn the public and when to begin evacuations. The oracle's task becomes far more difficult when it turns to earthquakes. Here, prediction in the precise sense remains beyond our grasp. We cannot say when a major quake will strike, but we have moved profoundly beyond helplessness. The modern oracle for earthquakes is one of forecasting and early warning. Seismologists work to identify fault lines and understand their history through paleoseismology, digging trenches across faults to read the history of past ruptures in the layers of sediment. This tells them the where and the how often. They can calculate the potential maximum magnitude of a future quake and estimate the probability of it occurring within a given time frame, like decades. This is the long-term forecast that guides building codes and infrastructure planning. The most dramatic technological advancement is the development of earthquake early warning (EEW) systems, like Japan's renowned system. This is not prediction, but a race against waves. When a fault ruptures, the energy radiates out in seismic waves. The fast-moving but less damaging P waves travel faster than the slower destructive S waves and surface waves. Networks of seismometers detect the P waves at the epicenter and instantly transmit a signal which can travel at the speed of light ahead of the damaging shock waves. This provides a precious few seconds to a minute of warning. It is enough. Time for trains to automatically brake, for surgeons to pause delicate operations, for factory assembly lines to shut down, and for people to dive under a desk. It is a technological sigh of relief before the roar. This modern oracle is humbling. It does not grant control, it offers a glimpse. It is a system of probabilities and uncertainties, a constant battle to interpret ambiguous signals. Sometimes the mountain swells and then settles back down without erupting. Sometimes a quake strikes a fault that was considered dormant. The earth still holds its secrets close, yet this shift from myth to monitoring represents one of humanity's greatest intellectual achievements. We have moved from appeasing the gods to reading the data. We have replaced fatalism with forecasting. The goal is no longer to predict the exact moment of anger, but to understand the building temper, to recognize the signs of agitation, and to use that hard-won knowledge to buy time, to save lives, and to stand not in superstitious fear of the Earth's power, but in respectful, watchful dialogue with it. The oracle does not tell us the future, but it tells us how to listen. There is a paradox at the heart of the Ring of Fire, a place where unimaginable destruction wears a mask of breathtaking beauty. For all the terror and loss they bring, volcanoes are also among nature's most sublime artists. Their eruptions are not merely events of geologic force. They are performances of light, sound, and form on a planetary stage. To witness the fury of a volcano is to be confronted with a spectacle so raw and powerful that it transcends fear and touches something deeper, a profound, humbling awe at the beauty inherent in the Earth's creative violence. The curtain rises with the eruption column itself. A superheated plume of ash, gas, and pumice rocketing miles into the atmosphere is a terrifying force, but from a distance it is also a staggering sculpture. It billows and evolves, its shape shifting from a brutal, cauliflower-like crown to a vast, anvil-headed cloud that can blot out the sun. At sunset or sunrise, this same destructive cloud becomes a canvas for the most brilliant colors. Ash and aerosols scatter the light, painting the sky in lurid shades of orange, blood red, and deep purple, a phenomenon known as volcanic twilight. The sky itself becomes a work of art, a daily reminder of the eruption long after the initial blast has faded. Then comes one of nature's most electrifying phenomena, volcanic lightning. Within the ash cloud, countless particles of rock and ice collide violently, building up massive static charges. The result is a continuous, silent storm of lightning that crackles within the heart of the darkness. These are not single bolts from the sky to the ground, but vast spider-webbing networks of electricity that illuminate the entire cloud from within. It is a celestial light show raging inside a torrent of hellish debris, a perfect fusion of the terrestrial and the atmospheric, of chaos and dazzling light. It is the Earth illustrating its own power with strokes of brilliant, terrifying electricity. As the eruption progresses, the focus shifts to the flows. There is the slow, relentless advance of an AR lava flow, a clinking, grinding river of razor-sharp rock that moves with the sound of breaking glass. It is a destructive bulldozer, but in its wake, it leaves a landscape of incredible texture, a black, ropey, alien surface that gleams under the sun. Its counterpart, Pahoho, is the artist's more fluid medium. It flows in smooth, undulating folds like a river of black glass. As it cools, it forms mesmerizing patterns. Coiled ropes, elephant skin, and long, sinuous tubes. To walk on a recently cooled Pahoho flow is to walk on a sculpture of the Earth's own making, a snapshot of its motion frozen in stone. At night, the volcano's art becomes elemental and pure. The incandescent heart of a lava flow or the glow of a lava lake within a crater provides the only light. It is a primal fire, the planet's inner heat made visible. Against a backdrop of absolute darkness, the red-hot rock cracks and cools, its surface a constantly shifting mosaic of black crust and orange liquid fire. To watch this is to understand why our ancestors saw dragons and gods in the mountains. It is a vision of life itself simmering just beneath a thin, brittle shell. And there is the strange, ethereal beauty of the pyroclastic flow itself, the most deadly product of an explosive eruption. From a safe distance, its deadly nature is momentarily obscured by its astonishing appearance. A boiling, turbulent cloud of hot ash and gas races down the mountainside at hundreds of kilometers per hour, but it moves with a surreal, graceful fluidity like an avalanche of smoke. It follows the contours of the land with a terrifying sentience, and as it billows upward, it creates forms that are both beautiful and ghastly. It is a wave of annihilation that looks for a fleeting moment like a phantom wave crashing in slow motion. This beauty is not a comfort. It is a complicating, haunting truth. It forces us to hold two contradictory ideas in our minds at once, that this very phenomenon can erase cities and lives in minutes, and that it is also one of the most visually magnificent events on the planet. It challenges our simple categorizations of good and evil in nature. The volcano is neither. It simply is. Its beauty is amoral, existing independently of its destructiveness. This is the art of the eruption. It is the proof that our planet's most violent processes are also its most creative. The same forces that can end a world are the ones that built it. The ash that chokes the sky will one day fall and become the most fertile soil on Earth. The lava that burns a forest will eventually weather into new land. To see the beauty in the fury is not to dismiss the danger, but to understand the complete picture. That creation and destruction are not opposites, but partners in an endless, beautiful, and terrifying dance. It is the Ring of Fire's most profound lesson written in light, fire, and stone. The same fire that forges continents and levels landscapes also holds a profound, gentle secret. For all its capacity for violence, the simmering heart of the Ring of Fire is also a source of deep rejuvenation. The tectonic forces that breed catastrophe also fuel a quieter, more sustaining power, geothermal energy. This is the volcano's other face, not one of fury, but of healing. It is a gift of warmth and wellness drawn directly from the Earth's inner heat, a reminder that from the same source of destruction can flow immense comfort and sustenance. This alchemy begins with water and a fault line. Rainwater and snowmelt seep deep into the fractured crust, following cracks and pores downward. As it descends, it approaches the deep-seated heat source, a cooling magma chamber, or simply the intense temperatures found near active faults. The water is superheated, but under pressure, it cannot turn to steam. It becomes a fluid of immense energy, capable of dissolving minerals from the surrounding rock. This hot, mineral-rich water then begins to rise back toward the surface, following the path of least resistance, often through the same fractures that allowed its descent. When this heated water emerges naturally, it creates the world's hot springs and geysers. In Japan, the tradition of onsen is a cultural cornerstone. These are not mere swimming holes, they are revered places of ritual cleansing, social bonding, and therapeutic healing. Soaking in the silky, sulfur-scented waters of an outdoor onsen, often with a view of the very mountains that heat them, is to participate in a centuries-old practice of communion with the Earth's energy. The minerals, sulfur, calcium, magnesium, are absorbed through the skin, said to alleviate aches, improve circulation, and soothe the spirit. It is the volcano's warm, welcoming embrace. In places like New Zealand's Rotorua, the geothermal field is so active that the entire city lives atop a steaming landscape. Pools of bubbling mud gurgle like cauldrons, and geysers erupt with clockwork regularity, shooting plumes of hot water and steam into the air. The air itself carries the distinct, pungent scent of sulfur, a constant reminder of the powerful forces at work just below the sidewalk. Here, the boundary between the natural world and the urban environment dissolves. People cook in natural steam boxes and heat their homes with the Earth's own energy, living in direct, daily partnership with the geothermal gift. But the most transformative application of this power is geothermal energy. Here, we move beyond bathing and into the realm of high technology that harnesses the volcano's might. Engineers drill deep wells into these active regions, tapping into reservoirs of steam and hot water. This high-pressure steam is piped to the surface and used to spin turbines, generating electricity. Unlike solar or wind, geothermal energy is a baseload power source. It provides a constant, reliable, and clean stream of energy 24 hours a day, regardless of weather. Iceland, a nation born of the mid-Atlantic ridge, is the global master of this technology. Nearly 90% of its homes are heated directly by geothermal water, and over 25% of its electricity comes from geothermal power plants. This has freed the nation from a dependence on fossil fuels and given it incredible energy independence. The city of Reykjavik is heated by water pumped from wells far underground, a district heating system that makes the air clean and the cost of living in a frigid climate surprisingly low. The Blue Lagoon, world famous for its milky blue, mineral-rich waters, is actually a runoff from a nearby geothermal power plant, a stunning symbol of how industry and wellness can coexist. Born from the same source, this represents a profound shift in the human relationship with the Ring of Fire. For millennia, its energy was something to be feared and appeased. Now we are learning to partner with it, to plug directly into the Earth's engine and draw upon its power for light, heat, and stability. It is the ultimate recycling, using the planet's own internal heat to power our societies without polluting the atmosphere. The geothermal gift is thus a story of balance. It is the Ring of Fire's offer of reconciliation. The same subduction zone that can unleash a megathrust earthquake also creates the fractures that allow us to tap this clean energy. The same magma chamber that might one day feed a catastrophic eruption is, for now, quietly heating water for a community spa or generating electricity for a city. It teaches us that the Earth's power is not inherently good or evil, it is simply a force. Our challenge and our opportunity is to learn to live with it, to respect its fury, but also to accept its generosity. In the steam rising from a hot spring and in the quiet hum of a geothermal turbine, we find a promise that from the very heart of the fire there is also healing.